Hey everyone, welcome to new series for embeddings. So in this particular series, we are going to cover everything related to embeddings from vector databases. We are going to have a look at different vector databases available like ChromaDB, Milvus or VV8 or Pinecone. So we are going to have a look at those particular databases. But for this particular part 0, I'm just going to explain you what embedding is. And at the end of this video, we'll have a project something like there are 4 different products, and based on the user query our script will going to recommend us the product. So it will be something like that. So keep an eye at the end of this video for this particular project. So first of all, what is embedding? Let me change the color. So in simple words, embedding is nothing but a vector of floating point values. Okay, so embedding is just a way to represent a text, a image, or in fact a audio as well. So what embedding do, it takes as input of text. Suppose this is our embedding model, and it returns us the vector of floating point values. In case of image embedding models, it takes in the image and it returns the floating point vector. In terms of audio, it takes in the audio and returns the floating point vector. Now you might be asking, like, if it's just returning floating point vector, so what is a big deal in it? Like, what is something important in this floating point vector? So I'm just going to explain you this thing by a very simple example. Then you will have a better understanding like what exactly this floating point vector is doing. The first benefit, I'd say, like, it is used in dimensionality reduction. Suppose you have text, a long paragraph or long sentences, and it is going to convert it to a vector of, let's say, just 348 different floating point values. If we talk about sentence transformer, which is a open source model, which we are going to see at the end of this video. So let's just keep the thing simple right now. So for understanding what is inside a floating vector, suppose I have a embedding model which takes input text and gives me output floating vector of dimension 2. So it will going to output me 2 different floating point values instead of 348. Suppose I give input string as animal to my embedding model and it returned me 1,2. Suppose I give it bird and it returned me floating point vector of, let's say, 2, 3.0, and I gave it fruit and it returned me vector of 3.0, 2.0. Now the good thing about this that I can plot these values. So let's see what will going to happen if I plot these values. So animal will be something over here, I'll just call it animal, and bird will be something over here, 2 and 3, and fruit will be something like 3 and 2. This is my fruit. Now suppose a new query came, dog. Now when I pass dog to my embedding model, it is going to return me a vector of 2 different floating point values. But the good thing about these floating point values that it will be close enough to its category. So it will be something like, let's say for animal it was 1 and 2. For dog it might be 0.5, 0.5. So it will be something over here. So you see, if I just want to query my documents, suppose I have huge amount of data set, I have huge amount of sentences, and I want to query some question from a paragraph of huge text, then I can get a most relevant paragraph. Or maybe if we talk about Google search engine, there are huge indexes available, and based on the user query, the most closer one indexes came to us at just lightning speed, right? So it is something like that. You'll get a better understanding when we implement a simple script at the end of this video, but for now understand it like that. So embedding model takes in maybe text, image or audio, and based on the input configuration of the embedding model, which is a deep learning model, it outputs a vector of floating point values depending on the output neurons. For example, in sentence transformer it is 348. For OpenAI embedding it might be something different. For our simple test case, simple understanding, it is 2. Now while we are at this, what are vector databases? Now you understand database is like storing the data so that we can retrieve it later on more efficiently, and vector database would be storing vectors such that we can retrieve them later on efficiently. And vector is nothing but the embedding which is generated by the embedding model. That's it. Okay, so I guess now you have a better understanding what embeddings are. If you still not able to get, I'll link down some blog posts, you can read them out. But still, if you have small queries, you can ask them in down comment section. Now let's move to fun part. The theoretical part is over. Let's move to fun part. Alright, so here we are in our interactive Python notebook. This is VS Code, by the way, I'm using. Now suppose Amazon gave me a task to build their recommendation engine, or maybe for their marketplace based on the user query. They asked me to return the most relevant products. So for example, let's say user query is smartwatches. So user want to shop for smartwatches, and my application should output most relevant smartwatches out there. For example, it should output Apple Watch Series 7 available for like this. So let's see how we are going to do that. So this is a list of different products I am having. I have 5 different products, and we are going to use sentence transformer for generating embeddings. We are going to use sentence transformer for calculating the nearest string or nearest embedding. So as you see over here, when we generated the embeddings and plotted it, so the task which we did visually, we calculated that this particular point is close enough to this particular point. So this particular task will be done by this util, and we are importing numpy just for creating arrays. Now we are going to initialize our sentence transformer by this open source all mini lm l6 v2. Let's run them. Now we are going to generate the embeddings of the model. So we are just going to iterate in our products list, which is this particular list, and we are going to use model.encode to encode that particular into embedding, and we are going to store that inside embeddings list, and we are going to convert that to a numpy array, and then we will going to see the shape of the array. So shape you see as 5,384. As I told you, here we had 2 length floating point embedding vector, but for our open source model it is outputting 384 dimensionality vector. Now this is the user query, which is smartwatch, and this query has to be converted to embedding once again, as we have seen over here. So the query dog was converted to embedding. Similarly, user query will also have to be converted to query embeddings. Now if you are interested, let me just show you how this query embedding look like. So you see it is just a array of floating point values, as I told you, and for calculating the closeness of all the embeddings, here we have calculated visually, but for doing this there is a mathematical formula called cosine similarity. So we are going to pass our query embedding and product embedding, and we are going to extract out the 0th vector, since it's a array of array. So we are going to extract 0th array, and we are going to convert it to numpy array, and I'm just going to show it to you how does this look like. And then we are going to sort in descending order to get the highest score on the top. So it is something like that. So you see 21% score, 46% score, the highest value is at this index, something like that. Now we are going to show the result by just showing through the index and from the products, and as you see over here, we are getting the highest score at Apple Watch Series 7, and later on we got score of 21% as S22 Ultra. Now suppose I'll just delete this particular cell. Now suppose the user want to shop for, let's say, 5G phone, and we will generate the embedding. We will calculate the cosine similarities, and we will show results to the user. So we got the highest probability of Samsung S22 Ultra 5G. There is a phone which is multimedia keypad phone, then we got the Apple Watch, then Apple AirPods at the end. Now suppose user want to shop for earphones. So here you see JBL earphones on the top, then Apple AirPod on the top, and then this iVoo phone, multimedia keypad phone at the third. So this is what embedding is. I guess you get a real understanding, and you get both theoretical and both practical understanding and how to use this. I'll leave this code in down description, as well as I don't think like this is going to be useful. In case you need it, let me know, but I'll just leave this code in down description. So this is it for part 0. If you still have any doubts regarding embedding, please let me know. I'll just clear that in next video. So till then, keep searching for embeddings, because a lot of content is about to come. Also subscribe, because a lot of content is about to come. So that's it. Goodbye.